The SCR or silicon control rectifier is often referred to as a PNP junction because it is made by joining four layers of semiconductor material. Notice that the symbol for the SCR is the same as the symbol for diode, except that a gate LED has been added. The SCR is a member of the family of devices known as thyristors. These devices are digital devices in the sense that they have only two states, on and off. The SCR is used when it is necessary for an electronic device to control a large amount of power. For example, assume that an SCR has been connected in a circuit such as the following image. When the SCR is turned off, it will drop the full voltage of the circuit and 200 volts will appear across the anode and cathode. Although the SCR has a voltage drop of 200 volts, there is no current flow in the circuit. The SCR does not have to dissipate any power. In this condition, 220 volts times 0 amps equals 0 watts. When the push button is pressed, the SCR turns on, producing a voltage drop across its anode and cathode of about 1 volt. The load resistor limits the current to 2 amps since the SCR now has a voltage drop of 1 volt and 2 amps of current flowing through it. It must dissipate 2 watts of heat. Notice that although the SCR is dissipating only 2 watts of power, it is controlling 400 watts of power. When an SCR is connected in a DC circuit, the gate will turn the SCR on, but it will not turn the SCR off. To turn the anode, cathode section of the SCR on, the gate must be connected to the same polarity as the anode. Once the gate has turned the SCR on, and the SCR will remain on until the current flowing through the anode, cathode section drops to a low enough level to permit the device to turn off. The amount of current required to keep the SCR on is called the holding current. In an AC circuit, the SCR is a rectifier. When it is connected in an AC circuit, the output is direct current. The SCR operates in the same manner in an AC circuit as it does in a DC circuit. The difference in operation is caused by the AC waveform falling back to 0 at the end of each half cycle. When the AC waveform drops to 0 at the end of each half cycle, the SCR turns off. This means that the gate must retrigger the SCR for each cycle it is to conduct. Assume that variable resistor connected to the gate has been adjusted to allow 5 milliamps of current to flow when the voltage applied to the anode reaches its peak value. When the SCR turns on, current will begin flowing through the load resistor. When the AC waveform is at its positive peak, current will continue to flow through the load until the decreasing voltage of sine wave causes the current to drop below the holding current level of 100 milliamps. When the current through the anode, cathode section drops below 100 milliamps, the SCR turns off, all the current flow stops. The SCR will remain turned off when the AC waveform goes into its negative half cycle. Because during this half cycle the SCR is reverse bias and cannot be fired. If the resistance connected in series with the gate is reduced, a current of 5 milliamps will be reached before the AC waveform reaches its peak value. On a phase shifting circuit, the SCR can control all of the positive waveform through the use of phase shifting. As the term implies, phase shifting means to shift the phase of one thing in reference to another. In this instance, the voltage applied to the gate must be shifted out of phase with the voltage applied to the anode. An SCR can be tested with an ohm meter. To test the SCR, connect the positive output lead of the ohm meter to the anode and the negative lead to the cathode. The ohm meter should indicate no continuity. Touch the gate of the SCR to the anode. The ohm meter should indicate continuity through the SCR. When the gate lead is removed from the anode, conduction may stop or continue depending on whether the ohm meter is supplying enough current to keep the device above its holding current level. Thank you for watching, and please remember to like, share, and subscribe.